side by side. With the wire feed gun angled a little to build up weld, use the edge of the bevel to keep the bead straight. Then use the inside edge as a guide, adjusting the travel speed to allow the puddle to flow almost to the middle of the first pass. If the final pass needs to be smaller, hold the gun more perpendicular and increase the travel speed for a narrower bead. In any welding position, flat, horizontal, vertical, or overhead, running hot and straight, stacking as many beads as it takes is the simplest way to fill and cap heavier metal. A fillet weld is used on both lap joints and T-joints, and the technique for both is very similar. Direct the wire into the corner, slightly towards the bottom piece. The work angle determines the position of the fillet in the joint. Angle the wire feed gun to help push the puddle up. Holding the gun more perpendicular to the weld will produce a flatter bead, and when necessary, allow you to travel faster for less weld deposit. Angling the gun slightly back will build up more weld and produce a slightly crowned weld bead. Keep the wire towards the front of the puddle for good weld fusion in the bottom corner. On heavier metal, stack up overlapping beads to build up the required amount of weld. Fillet welds are pretty easy with gas-shielded flux core. Just make sure the puddle and slag stay back behind the wire. If molten metal floats in front of the wire and you push the puddle, there is a good chance the bottom corner will not be fused. Corner joints can be fit up with one-piece bevel or by butting the inside edges of square cuts. On thinner metals, open the bevel up so you can control the puddle in the bottom of the joint. On heavier metals, a smaller bevel is often used to reduce the amount of weld deposit and time it takes to complete the joint. The beveled side is going to heat up quicker. Angle the gun as necessary to allow the puddle to flow out and tie into both pieces. On an outside corner, because of the amount of heat and filler metal deposit, the weld will try to sag. For thinner metals, holding the gun more perpendicular to the weld along with a faster travel speed will help keep the base metal and molten puddle cooler. As the metal thickness increases, it may take two passes, the first filling to the bottom corner, the second filling to the top. On heavy metal, bring the filler deposit up and out evenly, leaving a little of the edges for the final weld. Every type of weld joint in any position is made one weld bead at a time, and it always comes back to controlling the wire extension, gun angle, and travel speed. Even though it's hot, with a considerable amount of weld deposit, gas-shielded flux core is not complicated. Don't be bashful. Turn up the heat, run straight, and keep it simple. Well, I hope I've given you an idea about flux core arc welding. With moderate deposit rates, the self-shielded wires are used for structural, fabrication, and repair outside the shop. They're also an excellent type of wire for the smaller wire feed machines. Gas-shielded wires with higher deposit rates are used inside the shop for heavy fabrication and repair. Choose the type of wire for the projects you're working on and understand the characteristics and parameters of the specific wire you're using. Watch the puddle and practice developing the skills to control a wire feed gun and figuring out just what works for you. Take your time, have fun with this, and above all else, work safely.